So here, what I'm gonna do, so see section 2.3 homework number 18. So I think it's 16, 17, 18, 3 problems about inequality problems. Okay, so, but they are not linear inequalities. We learned that how to solve linear inequality in chapter 1, right? But here, as you can see that to see to solve the following inequality, 3 minus 7 times absolute value of x is less than or equal to 0. Yeah, I know. So what we saw similar problems in chapter 1, right? But let me um, find the solution set by grabbing the 3 minus 7 times absolute value of x, okay, using the transformation, what we learned 2.3, okay? So now, just give me a second. All right, so here, what are you gonna do? So problem is this, right? 3 minus 7 times absolute value of x is less than or equals 0, right? Okay. Okay. So now, the first one, we're gonna consider 3 minus 7 times absolute value of x as the function, okay? So let's say the f of x defined by 3 minus 7 times absolute value of x, okay? So keep in mind is f of x is what? The function notation, right? So that's the actually means the y, right? Okay. So now then this inequality can be expressed as, that's the equivalent notation, okay? This is can be expressed as y is less than or equal to 0, okay? So what that means, we want to find out the inverse of x. That's the solution set, okay? So it's inequality solution set here. What means the what the set of all the x value or x coordinate, their corresponding y values are less than or equal to 0. That's a goal. Okay, so please keep in mind this concept. Okay, so a little bit quite complicated, right? But um, you need to fully understand what I'm going to do. Okay, so because we're gonna see this kind of strategy. Okay, later. Okay, so now anyway, so keep in mind this. We first of all yeah, definitely we're gonna set 0 on one side, okay, but we already got 0 on the right hand side. That's the very first step. And step 2, set the left hand side as function. Okay, yeah, so we set f of x 3 minus 7 times absolute x. Then this inequality can be interpreted as what? Y, find the set the solution set, which means that the set of all the x value whose corresponding y value is less or equal to 0. Okay, so now then what so to find out the set of solution set, the set of the all x values, x coordinates satisfying this inequality, I'm going to use the transformation. Okay, so I'm going to find out that solution set by grabbing the function f of x using the transformation. Okay, so the how can I do that? First, you see that absolute value of x is right there. So we're going to start from the graph of the absolute value function. This is one of the basic function introduced in section 2.2, right? So I told you, please memorize every single the graph of functions introduced in 2.2. Keep in mind this. So we can start from the absolute value of x. Then to what? Using transformation, we're gonna express the f of x in terms of g of x. Okay, so see that negative 7 right there. So that's the actually what stretching and reflection, right? So first we apply stretching, okay, by a factor of 7. 7. Then we're gonna get the 7 times g of x, which is 7 times absolute of x. Okay, and then now what we just the next 7 to get the -7. That's the reflection about the x-axis. So please memorize the 4 transformation: Fourier translation, stretching, shrinking, reflection, and Fourier translation. So please keep in mind those transformations. So now the reflection, okay, about the x-axis. Okay. So that's going to be -7 times g of x. This is equal to -7 times absolute of x. Okay. And now the next one, you see the 3 right there, plus 3, right? So it means the Fourier translation, right? Shift the graph of -7 times g of x upward 3 unit. Okay. So this is VT. So we have -7 times g of x plus 3, which is a -7 times absolute of x plus 3. This is the what? That is the f of x, right? This is f of x. Okay. So starting from the graph of the v of x, y-axis, x-axis. So the graph of absolute of x is this, right? Okay, this is the graph of g of x. Then now what? We stretch the graph of g of x by a factor of 7, then we'll make it this. Okay, so yeah, let's figure out the the difference difference of y coordinate, the same x coordinate between two graph. Okay, this is, by the way, this is 7 times g of x. Okay, it means y just graph is just the width between two straight lines just got narrowed, because when x equals, for example, 1, okay, then the point on the g of x whose x coordinate 1, its corresponding y coordinate is 1, right? So here's 1. So this is 1 comma 1. That's the ordered pair of the point. But in 7 times g of x, when x equals 1, we're going to get not 1 but 7. So here's a 7. So this is 1 comma 7. Okay. So not only 1, but every single the x coordinate, their corresponding y coordinate will be the multiple. Okay, multiplied by 7. Okay. So that's why the graphic just we're going to get this kind of graph for the 7 times g of x. Now, next one is reflection about the x-axis. So we're going to reflect the graph of the g of x, 7 times g of x about the x-axis, so we'll get this. Okay, so that's the -7 times g of x. Okay, so when x equals 1, we're going to get not +7, but -7. Okay, so right there, this is 1 comma -7. Okay, and then see the VT. So we're gonna move the graph of the negative times 7 g of x, -7 times g of x upward 3 units. So then the point moves upward 3 unit, 1, 2, 3, maybe 3 right there. Okay, so we're gonna get this. Okay, so that's the graph of the -7 times g of x plus 3, which is the what? Graph of f of x. Okay, so now that's not done. That's not the answer. Okay, so the goal is to find the what? The solution set of this inequality. Okay, but we have rewritten this inequality as this. Okay, so let's find out in what interval of x their corresponding y value is less than or equals 0. It means the graph should lies below the x-axis, right? So you see this part, these two one. So from here to negative infinity to that point, and then from this one to infinity, those two intervals, their corresponding y coordinate is what? Less than 0. How come? Look at the graph. Graph lies below the x-axis. It means that what? For every single the x coordinate in this interval, their corresponding y value is negative. Okay, you see that? So now then what? It turns out that what we have to figure out those 2 points, which are what? X-intercept. Do you remember the x-intercept what it is? X-intercept means the what? Intersection point between the graph and x-axis. Okay. So let's see, that was actually step 1. Okay, this is step 2, right? Step 1, okay, and then step 0 is what make this getting 0 on the one side, okay, normally right hand side. Then step 1, set the left hand side as a function, and then step 2, using transformation, plot the graph of the function, okay, and then step 3, yeah, find the x-intercept of the graph. Okay, so how can I find the x-intercept? Excuse me. The what? So those two x-intercept, their what? Y coordinate must be 0, right? Because these 2 points lies on the x-axis. It means that those 2 ordered pairs, their y coordinate must be 0. Okay, so we have to find x. Oops, sorry, find x such that what? The f of x equals 0, right? So what's the f of x then? F of x is defined as what? 3 minus 7 times absolute value of x, right? So it means that we have solved what? 3 minus 7 times absolute value of x equals 0. Okay. So the solution of this equation must be x coordinate of x-intercept. Okay. So there, we solve 3 minus 7 times absolute value of x equals 0. Then what? We have to isolate absolute value of x, right? Because yeah, we learned how to do this, right? In chapter actually 1.1, right? This is a linear equation with one variable involved the absolute value of x, right? So yeah, first we isolate absolute value of x, which is what? 7 over 3, right? 7 over 3. Oh, sorry, it should be what? 3 over 7, right? Sorry. So now the x must be what then? Plus minus 3 over 7, right? Okay. So it means that this point must be what? Minus 3 over 7. Okay, this point. And then that point, I mean, x coordinate, okay, this x-intercept must be positive 3 over 7. Okay. So the answer is what then? So let me write down here. Answer must be negative infinity 2, negative 3 over 7. Do I have to use a closed interval or open interval? It's closed interval, right? Because there's equal sign. There's equal sign. So when x is negative 3 over 7 and x is 3 over 7, we're gonna get 0 as y value. Okay, so just use close. And the union, positive 3 over 7, close, positive 3 over 7 to infinity. Okay, so please keep in mind this step. Okay, so we're gonna revisit that strategy when you study quadratic function. Okay, so keep in mind this. Next problems. Let's see, give me a second. So we move to the okay. Solve the inequality by graphing an appropriate function. State the solution set using interval notation. Okay, so Yeah, so okay, so we're gonna this is also problems covering the objective, same objective. Okay, so the solving inequality by reading the graph. Okay, yeah, so let's try uh, to solve the problems. Okay, so see x minus 7 square minus 9 is less than or equal to 0. So actually what x minus 7 square minus 9, we can plot the graph of this function. I mean, considering the left-hand side as a function f of x, then we can plot the graph of f of x starting from the graph of the square function. Because you see that x minus 7 square, we can get x minus 7 square by shifting the graph of the x square, which is a square function, parabola, I mean, to the right 7 unit, right? So let's see here. Okay, so now x minus, this is problem number 17. Okay, number 17. Okay. So the x minus 7 square and the minus 9 is less than 0. Okay. Yeah, so let's say f of x is kind of step 1, right? F of x we defined as x minus 7 square minus 9. Okay. And then in a g of x, it is just x square. Okay. So now then what? Now step 2, we apply the transformation to plot the graph of f of x. Okay. So starting from g of x is x square. Do you see the x minus 7 square? We can get x minus 7 square using HT, horizontal translation. Okay. So actually shifting the graph of g of x to the right 7 unit, right? So now we're going to get g of x minus 7. Okay. This is equal to x minus 7 square. Okay. So I explained why the replacing the dummy variable of the first coordinate, the g of x, function g, by x minus 7 means that horizontal translation of the graph of g of x to the right, not left. I explained this one, right? So if you understand this one, then you barely confuse the between the horizontal the h to the right or h2 to the left. Okay, so when you get this x7 minus 7, it sounds like that you have to plot the shift the graph of g to the left, right? Because normally left sign means just left, right? And the plus sign means right, but this is opposite. Why? Because think about the graph of g of x. I mean the square function, right? Then see, when x equals 0, we're gonna get 0 as y value. This is 0, 0, right? But in this one, g of x minus 7, what x value we're gonna get the x y coordinate 0? 7, right? So when x equals 7, we're gonna get 0. So 7, 0 actually right here. That means that point moved to the right 7 unit. Okay, that's why the g of x minus 7, the graph of g of x minus 7 is actually shifting the graph of g of x to the right 7 unit, even though this is negative sign, negative 7. Okay, so right here, this is a g of x minus 7. Okay, all right, anyway, so let me keep going. So we got the x minus 7 square, and this is a negative 9. That means what? We apply the VT vertical translation, 9 unit downward, right? Okay, so we're gonna get g of x minus 7 and then minus 9, which is the x minus 7 square and then minus 9. Okay, so okay, so yeah, let's plot the graph of f of x. Okay, so it's not a big deal, right? So y-axis, x-axis, the graph of g of x right there, g of x, and then I'll move to graph of g of x to the right 7 unit. Okay, so maybe right here. Okay, so that's the g of x minus 7. So right here is a 7 right there. Okay, is 7. Okay, and then we shift down 9 unit, right? So then that 7,0 moved down to 7 unit, 1, 9 unit. Okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here, 9. Okay, here. So the graph must be like this. Oops, should like this, sorry. Okay, so this is gonna be graph of f of x. Okay, so see here and here. Okay, so now what are you gonna do? So now step 3 is what? We have to find out the x-intercept, right? See that x-intercept right here, and then right there. Okay, why we have to find out the x-intercept? Because back to the problems. Don't forget that, well, the goal is to find the solution set of that inequality, right? Okay, but since we set this one, x minus 7 squared minus 9 as a function, right? F of x. So we want to find out the solution set where f of x is less than 0. Okay, so then in a view of graph, we want to find out a number on the x-axis where graph lies below x-axis. Okay, see, then what? From here to, we have to use opening number, right? Why do you understand why we have to use open number? Because you see that less than, look at the inequality, there is no equal sign, so we got to use open. So it's open, open. From here to here, all the x coordinate within that number, their corresponding y coordinate is what? The it's negative, right? Okay. So for example, I just pick the one x coordinate within the number, then just figure out the y sine of y coordinate. Definitely negative, right? Right there. Okay. So then what? What are they? I mean, we need to figure out what those 2 points, right? Actually, these are what x-intercept, right? So we solve to find the x-intercept. I mean, x coordinate of x-intercept. We have to solve what f of x equals 0, right? It means that x minus 7 squared minus 9 equals 0. Okay. So yeah, this is what quadratic equation. We learned that how to solve quadratic equations, right, in chapter 1. So fortunately, what we got the perfect square from, right? X minus 7 square. So we're gonna isolate perfect square and then applying the square root property. Then we can get solution, right? So the x minus 7 square is equal to 9, right? And then we take a square root. X minus 7 square is equal to plus minus square root 9. Okay, don't forget the plus not minus sign. Okay, that's the key in the approximate the square root property. Okay, so then the right hand side gonna be just plus minus 3, and the left hand side square root square cancel them out. So we got x minus 7 is equal to. So it means that what x is equal to 7 plus 3 and 7 minus 3, right? It means that what 7 plus 3 is what 10. 7 minus 3 is what 4, right? So that must be 4. That point x intercept its x coordinate must be 10, right? Okay, 4, 10. Okay, 4, 10. So the answer is what? Opening number 4, 10 open. Okay. So now yeah, I'm sure that you are familiar with this step. Okay, step 1, 2, 3. Okay. So the now this numbers move to the number 16. Okay, so it's the last, I think, last example in the objective. Oh, by the way, yeah, so the problems ask you to plot the graph, right? So give me a second. Let me try to plot the graph. Okay. Give me a second. Give me a second. All right. So, yeah, I'm sure that you guys already know how to plot the graph, the online homework website, but let me show you. So we know that what I mean, we definitely we need to plot the parabola, right? So I just choose a parabola, okay, and then the we need to point the vertex point. Okay, what's the vertex point? So in the graph right there, in the parabola, for this case, the point, that point is called the vertex point, okay? It means that vertex point means that its y coordinate is minimum y value for this case. And then this kind of parabola, the vertex is right there, which means that its y coordinate is a maximum y value, okay? So, but since here we need to plot this parabola, then vertex is right there. Actually, we know the coordinate of that point, which is what 7,9, right? Is it? You see that is 7,9 right here. Okay. So let's see. All right. So 7,9. So we got 7 and 7, negative 9, right? I'm sorry, 7, negative 9. 7, negative 9. 7, negative 9 right here. And then vertical stretching, horizontal stretching, we didn't apply there, right? The vertical translation is what? Negative 9, right? Negative 9. Okay. And then horizontal translation is what? Actually 7, right? 7. Okay. See. Okay. Now you see that 4 and 10. So we can see that what the graph pass crosses 4, x equals 4 and x equals 10, right? So we see that the x-intercept must be 4, 0 and 10, 10, 0, right? So we can figure out the x-intercept by looking at the graph, by reading a graph. Or, I found the x-intercept 4, 10, 10, and the 10, 4, 0 and the 4, 10, 0 algebraic, right? So anyway, that's this answer right there. Okay. So now let's move to the next problems. I mean, problem number 16, okay? So now solve the inequality x squared in minus 25 is greater than or equal to 0 by reading the corresponding graph. Okay. So I told you, see, yeah, so what? This is a graph of the function x squared minus 25. So when you look at the inequality, we want to find the solutions. I mean, inverse on the x-axis where y value, I mean, f of x is greater than or equal to 0. It means that what? Negative infinity to negative 5. You see that here, negative 5, 0. This is x-intercept, one of the x-intercept, right? So negative infinity to the negative 5, closing number, including negative 5, their corresponding y value is greater than or equal to 0. Positive, I mean. Greater than or equal to 0. Non-negative, I'm sorry. Okay? So because you see that graph lies above the x-axis. And then from 0 to infinity, including 5, okay? Closing number 5 to infinity, but their y value must be greater than or equal to 0. So solution must be negative infinity to the negative 5, close, and then close 5, union, close 5 to infinity. Okay, so this is how to read the graph. Okay, so let me yeah, enter the solution. Okay, so negative infinity, right? Okay, to 5, negative 5, right? Close, and the union, see the union right here, and then close 5 to infinity. Okay, to infinity. Okay, so now let me see. Yeah, we did it, right? We did this. We found the solutions, right? So yeah. Now see number 15. Let's see. Yeah, let's see. Yeah, problem number 15. Okay, so let's see. All right. Mm, yeah, it's not. This is not a. Uh, it's not a big deal to find solution, but okay. So let me show you. I'll do it. So I believe that no, most of you guys can do it. Can solve these problems. But, hmm. Uh, yeah. Okay. So 2 times square root of x. Yeah. So we start from the graph of the square function, right? The y axis here, x axis, and the graph of the square root function is this. Let's say, let me use function notation g. Okay, g of x is square root of x. Okay. So now then, you see that 2 right there? That means what? This is equal to 2 times g of x. We can say that, right? So 2 times a function, it means the stretching vertically by factor of 2. Okay, so see stretch, okay, by factor of 2. So then we're gonna get 2 times g of x, which is 2 times square root of x. Okay. So now 2 times square root of 2, yeah. So when x equals 2, then here's the square root of 2, right? That's the y coordinate. I mean x coordinate, y coordinate on the of the point on the graph of 0 of x, right? 2 comma square root of 2, right? Okay. So then what about the what if you just stretch the graph 0 of x by factor of 2? Then well, we're gonna get this one, right? Okay. So when x equals 2, we're not gonna get square root of 2, but we're gonna get 2 times square root of 2, right? Okay. So this is 2 times 0 of x, which is what? The graph was 2 times square root of x, okay? All right. So now we're gonna find out the graph from the example, okay? Passing through 2 times square root of 2, okay? So let's see that. All right, so now look at this. The definitely B and D are not answer, right? B and D are not answers because you know, to get, you know, the graph like B, example B, what, the reflection about the x-axis must be involved in the transformation, okay? And then for D, yeah, reflection about the y-axis must be involved, okay? So the answer must be A or C. But look at the A. I mean, yeah. So see, I think so. You what? When see the when x equals 2, this is 2, okay? Because it's 2, 4, 6, 8, 10, okay? So one the unit means 2, okay? One block means 2, okay? So 2, 4, 6, 8, 10. So when x equals 2, the y coordinate corresponding to x coordinate 2 is not definitely around I think 1 point something or less than 1, right? So the A cannot be answered, right? So what about the C? C is a C. Let me see. Oh, not this one. Then when x equals 2, we see that the graph must be 2 point something, right? Okay. So 2 times square root of 2 is a 2 point, because square root of 2 is approximately 1.141. Then 2 times square root of 2 must be what? 2 times 282, approximately 2.3, right? So now when x equals 2, their y coordinate must be what? 2.3 something, right? So, okay. So I know it just looks like 3, but the I think C is the best the graph in the C describe the 2 times square root of x best. So the C must be answer. Okay. So now next one. Yeah, I think the problem, just 15 was not difficult, right? So now next one, let me see. Okay, here. Yeah, even function, odd function, and neither. Symmetric about the y-axis, symmetric about the origin. Yeah, let me talk about this in more detail, okay? So, because last lecture, yeah, I couldn't give a lot enough example. So, okay, so what's the even function and odd function? So if the f of x, oops, sorry, f of negative x, okay, f of negative x is equal to f of x, okay, then f of x is an even function, okay, and what the graph of f of x is symmetric about the y-axis. Oops. Okay, so keep in mind this. So even function means that what f of negative x is equal to f of x, and then graph of even function is symmetric about the y-axis. Okay, symmetric about the y-axis. So how come? Yeah, so let me figure out why. So what does that mean? F of negative x equals f of x. So remember that when I covered the reflection, one of the transformation, I gave 3 type of reflection, right? So one of them was the symmetric about the y-axis. I mean, let's think about this graph is like this, given. Okay, let's say this is a graph of f of x. Then the reflection about the x-axis here, x-axis right here, y-axis. Reflection about the x-axis means that the graph of f of x, I mean, reflect the graph of f of, I mean, flip the graph of f of x about the x-axis. So we got like this, right? Then what happened to the function? What happened to the equation of f of x? We got this negative f of x. Okay. So, and then the other one is that this reflection about the y-axis. I mean, it's just kind of out of blue. Why just we need to go over this one again because this is reflection about the y-axis related to that one. Okay, reflection about the y-axis. Y-axis. Sorry, I need more space, but please understand that. So then we'll get this. We'll get this. Then we got f of negative x. Okay, you see that f of negative x right there. Okay, so actually f of negative x is what? The graph of f of negative x is a reflection obtained by the reflecting the graph of f of x by the about the x-axis, y-axis. Okay, see, so the graph of f of x, right, is given, and the graph of negative x is obtained by reflecting the graph of f of x about the y-axis. And the f of negative x equals f of x. It means that their graphs are identical. Then what circumstance, their graph are identical? example is this. The square function. Okay. F of x is equal to x squared. Okay. So you see that when you flip the graph of f of x about the y-axis, we're gonna get still same the graph of the f of x, right? So reflection of the f of x about the y-axis, which is negative, f of negative x, its graph of negative, this guy is equal to graph of, is identical to graph of f of x. And then also, the equation of f of negative x is equal to x squared, because this is negative x squared, right? Which is x squared. Okay, this is one of the popular example of the even function. Okay, so that's why if function is even function, f of negative x equals f of x, then the graph of f of x is symmetric about the y-axis. Symmetric about the y-axis means that when you, so we can say, I told you, when you just flip the graph of f of x about the y-axis, we still get the same graph of the original graph, okay? Or we can say when you just cut the graph half and half about the y-axis and the fold one side to the other side, the graph is two graphs that exactly matched. Okay, so either one is fine. So I believe that you now understood what does that mean, symmetric about the y-axis. Okay, so even function means what? F of negative x equals f of x, and then every single even function is what symmetric about the y-axis. Okay, the other one is other function. By the way, so one more thing here. Not only x squared, actually every function. Let's say f of x is equal to x to the nth power. Every power function with the n is even are even functions. Okay, so it's here n can be what? 0, 2, 4, 6, 8, 10, 12, okay? So every the power function with the even power are even functions, so symmetry about the y-axis, keep mind this. Okay, now, and then also, sorry, one more things. The combination of even functions is the even function. Okay, combination of even function must be even function, keep mind this. So, what does that mean? So, for example, give me a second if you have example right here in the online homework, because I wanna give hint as many as I can. Okay, in online homework. Okay. Oh yeah. So see, problem number 12. Yeah, look at this. Determine algebraically whether the function is even, odd, or neither. Discuss the symmetry of the function. So look at this. 6 times x to the 8th power plus 3 times x to the 6th power. So the coefficient does not affect on the symmetric. Okay, even, odd function, or even function, odd function. Okay, keep in mind this. So just look at the power. Okay, x to the 8th power. So 6 times x to the 8th power. When you look at the just first term, okay, 6 times x to the 8th power. Since the degree is 8 even, so this must be 6 times x to the 8th power must be even function. And then what about second term? 3 times x to the 6th power, even function, because degree is even. So even function plus even function, even function. Okay, so this is even function. So what about the even function minus even function? Still even function. Okay, so keep in mind this. So that's one of the particular characteristic of even function. Okay, so or you can just back to 12 here. Oh, or you can just figure out the algebraically whether or not f of x is even, odd, or neither. So give me a second. So that's an example. Actually, problem number 12, right? 12. So think about this. F of x is given by, okay, so 6 times x to the 8th power and then plus 3 times x to the 6th power right there. Oh, can you see that? All right. So give me a second. It's so blurry, right? Okay. So now what are you gonna do? Yeah, we're gonna start from the we're gonna start from evaluating f of negative x. Okay. So f of negative x is f of x is given as 6 times x to the eighth power plus 3 times x to the sixth power. Then f of negative x is gonna be 6 times negative x to the eighth power plus 3 times negative x. Oops, negative x, right? To the sixth power. Okay. So then this is gonna be what? Negative x to the evens power gonna be just x to the eighth power, evens power, right? So we got 6 times x to the eighth power plus 3 times x to the sixth power, which is exactly the same as what definition of f of x. So starting from f of negative x, we end up with the f of x. So it means that what f of x must be even function. Okay. So you can do like that way algebraically, okay? Or just I told you just use the kind of the that characteristic of the even function. So combination of even function is still even function using that one. Okay, but that that property kind of property cannot be applied any cannot apply all of the even functions. Okay, keep in mind this. So now the let's see. Second question in the number 12. Okay, so determine the symmetry of function. Select the correct answer below, and if necessary, fill in the answer box to complete your choice. So function is not symmetric about an axis, but it is symmetric about the vertical line. Okay, what does that mean? I think that's the beyond of this subject, but let me explain about this. Symmetric about the vertical line. Yeah, so some function has that kind of line. Okay, the example is this. Think about this one. F of x is equal to x minus 5 squared minus 9. We saw that, okay, in the the previous example, online home problems, right? So the graph was y-axis, x-axis, here's a 5, and here's a negative 9. The graph was this, right? Okay, let's see. Sorry, this graph is not quite accurate, but sorry, but please understand that. Okay, so this is a parabola, right? So now think about that kind of vertical line, just vertical line passing through x equals 5. Okay, all right. So that the equation of this vertical line is x equals 5. Okay, also that vertical line passed through the vertex point right there. Okay, so then when you cut that parabola half and half about that vertical line, and then fold one side to the other side, then their graphs are exactly matched, right? So then it means that this graph is symmetric about that vertical line. Okay, so that's the example of the symmetry about the vertical line. But that kind of vertical line is called the axis of symmetry. Okay, then do we have to keep in mind this? Yes, we will go study um, about this one when you cover the when I cover the quadratic function. Okay, so every single quadratic function has such an axis of symmetry. Okay, keep in mind this. So yeah, I'm gonna go over this one later when I cover the quadratic function, but I just gave you this one today. But keep in mind this. So every single the parameter has the axis of symmetry, but the every single the parameter, well, that means what every single quadratic function, because the graph of quadratic function is parabola. So every single quadratic function has an axis symmetry. Okay, and it means that every single quadratic function is symmetric about the axis of symmetry, their own axis of symmetries. Okay, So that's the meaning of symmetric about the vertical line. And this is one of the particular example. Um, back to the problems. Okay. So determine the symmetry of the function to select the correct answer below. So, but f of x must be what? A symmetry about the y-axis. Why? Because f of x is even function. Every single even function is symmetric about the y-axis. Okay. So keep in mind this. So problem now next one is now I'm going to talk about the even other function. Okay. So let's see problem number 13, right? Okay. So I'm going to cover this and then just the call it a day. Okay. So now what are you gonna do? To do that, to work the problem number 13, you need to understand fully the definition of other function. Right? So if f of x, f of negative x is equal to negative f of x. Okay. So then the f of x is an other function. Okay. Okay, and the graph of f of x is symmetric about the origin. Oops. The origin. Okay, so what does that mean symmetric about origin? Yeah, maybe you forgot about this. Yeah, I'm gonna go over. Okay, so back to the transformation and reflection. Okay, so think about the graph of f of x is given like this, and then I'm gonna reflect the graph of f of x about the y-axis and then x-axis. Okay, then what happened? We're gonna get this, then we're gonna get this, right? Okay, so when you reflect the graph of f of x about the y-axis, then the equation of f of x will be changed to f of negative x, and then about the x-axis, we're gonna get negative f of negative x. That is called the reflection about the origin. Okay, so from here to here about the origin. Okay, so reflection. The graph of f of x about the origin is this. That is the reflection. The origin. Okay. Okay, like this. So now, okay. All right. Well, you may say that, okay. So, but when you look at the, the equation in the, definition of other function, we got f of negative x, but here negative f of negative x, where negative sign is gone. Okay. So you see negative sign right there. If you just move negative sign to left hand side, by the way, what does that mean? Just instructor keeps saying that they're moving the sign to left hand side or moving the number to the right hand side. What does that mean? It means that we multiply by -1 on both sides. Then right hand side, sign of right hand side gonna be positive, and the sign of negative side, left hand side gonna be negative, right? So that means sometimes I just keep saying that I'll say that just move negative sign to left hand side. It means that multiply -1 on both sides. Okay, like this. So then we got negative f of negative x is equal to f of x. Okay, you see that negative f of negative x? That's the reflection of the graph of f of x about the origin. So these two guys are equal. It means that their graph are identical. Okay, then what kind of example satisfy this? Yeah, guess what? The q functions. Okay, so y-axis, x-axis. So graph of q function is this. See f of x is equal to x cubed. Okay, so if you just reflect the graph of q function, the about the y-axis, we're gonna get this, right? And then reflecting this one about the x-axis, we're gonna get this, right? So we're gonna kind of back and forth, right? So that is equal to negative f of negative x. Okay, or if you don't get it, then yeah, I'll just show you why this guy is other function, why this guy satisfies this equation algebraically. Okay, so negative f of negative x is equal to what? Negative x cubed, right? This is equal to negative x cubed, right? This is x cubed. Okay, because the negative x cubed is what? Negative x times negative x times negative x, which is negative x to the third power. Okay, so we got this, which is exactly the same as f of x, right? But now in the cube function, guess what? F of x is equal to x to the n. So every single power function with the n is odd are what? Odd function. Keep in mind this. Okay. So now back to the problems. Okay. So give me a second. Yeah, determine algebraically whether so you may wonder that okay, in other function, does it have some kind of similar I mean property similar to what we use in even function? I mean other function plus other function is other function. Um, the answer is yes. Okay, the answer is other function plus other function minus other function still other function. Okay, so combination of other functions and other function. Keep in mind this. Okay, then can you apply this? Uh, yeah, but yes, but when you apply that, okay, say x cubed right there, this is other function. And negative 4 times x, I told you coefficient will not what affect on the what the even odd. Okay, so you don't have to take care of negatives, the coefficient x. Okay, so you see, just look at the degree of x. 1, other function. So x cubed is other function. And negative 4 times x is still other function. What about negative 4? Constant term. Every single constant terms what? Even function. How come? Because the negative 4 is the f of x is equal to x cubed minus 4 minus x minus 4. Okay. So now then negative 4 can be considered as this negative 4 times x to the zeroth power. For any value of x to the zeroth power is what? 1, right? So negative 4 can be considered as a negative 4 times x to 0. X to 0's power, right? 0 is an even number, right? 0, 2, 4, 5. So this, since the x to 0's power, this is even function. So negative 4 is even function. Or you can say, just plot the graph of negative 4. Okay, y equals negative 4 is right there, right? It's right here, negative 4. Okay. So negative 4 is what? Symmetry about the y-axis. It means a negative for every single constant function. Constant function must be what? Even function. Symmetry about the y-axis, I mean. What does that mean, constant function? It's kind of this. F of x equals negative 4. Okay? So in the definition of function, the only numbers are involved in the definition of f of x, then that is called the constant function. And the graph must be always horizontal line. Depending on the y value, depending on the value, in the definition, the height, the position of the horizontal line must be different. Okay, but anyway, so this is even, but that's odd. So combination of even and odd, well, neither. So the f of x is not odd nor even. Okay, or you can just show that just figuring out the f of negative x. Okay, so starting from f of negative x, okay, that's gonna be what? Negative x to the cube, and then negative 4 times negative x, and then minus 4. So this is equal to negative x cubed plus 4 minus 4. Okay, see. Do you think this is equal to the f of x? No, you see that? F of x is right here. I mean, let's see. F of x is right here. So I don't think, this guy is equal to f of x. then this is equal to, so it means, the f of x is not even function. Then is that equal to negative f of x? Negative f of x is what? Negative f of x is a negative x cubed plus 4x and then plus 4, right? Okay, so I don't think this is equal to this. You see that here's the constant term. Sine of constant term is a negative 4. The sine of that constant term is a positive 4. So these two guys are not equal. Okay, so you can do it like that way. Well, either one just fine. Okay, so back to here, and then the answer is neither. Okay, so that's for today. Okay, I'll take a roll, and then I'm gonna cover 2.4 next time. Okay, so please, 1 second.